Hold on, I'll find the jacks. Beautiful. We can't solve this using the method of converting to factor form. Can anybody guess another method we might use to solve here? Maybe it's like on your proficiency scale or something? Not maybe, it's like definitely on your proficiency scale.
We're just thinking, if I can't use factored form, are there any other forms we've learned about?
Well, we are going from standard form to factor form. Vertex maybe? Is it on your proficiency scale? What?
I do, I'm gonna print this real quick.
Okay. It is vertex form. It is. That is the next form.
And I don't want to be alone.
That's good, because he got a 9. He just throw it there.
There you go.
Alright. Oh, forgot to change that. That's what we did yesterday. We are still using open up resources, but now we're going to do how to convert from standard form to what form, Deshaun? Oh, we're not. Are we? Not converting. How to solve from vertex form? We're not converting.
We'll do both.
Was it just kidding? We're doing a little bit of both.
Right, because of the open up resources
Yeah.
pages here we pulled up.
Back to our proficiency scales. How many different ways do you need to show us you can solve a quadratic equation?
2.
2. 2 ways. I need to see 2 of the 3 ways. You should all, every last one of us, be able to do the zero product property in factored form, or with factored form. That's what it is.
Oh,
Go in the trash. Everybody's waking up late today.
I know.
Alright. Is that, oh, what do you do if you cannot factor? What do you do if you can't factor? What did we just talk about? They're not there. Nobody's there. Nobody's there. Alright, so back to your open up resources packet you guys have that we've been working on for a hot minute now. You should have this question: given the vertex form of quadratic, identify a vertex that accepts vertical, not vertical stretch. We're not doing that. Should be on right here. It's on the very last page, the very bottom. This is the last page of it, Patrick.
Yeah, that's not a problem. Number 4. Huh?
What about?
That's the problems they've already done.
Oh, that's
by
the same
factoring.
one?
Yeah.
Oh! Oh!
Wait, what paper? I don't know.
It's on the very last page on the back.
The idea is to see it from both perspectives.
So what we're gonna do here, who wants to guess what we're gonna do here? Vertical surfaces. We're gonna work through number 4 at our vertical surfaces with our groups. I do not want you guys to find the stretch. Again, we are not talking about that. Just get rid of that. But do find the vertex, x-intercepts, and y-intercepts. What form are we in right now? Vertex.
Explain what? I'm sorry.
What form are we in right now?
3.6.
Vertex form. What can you easily find in vertex form?
Vertex.
The vertex. Beautiful. Alright, 3, 2, 1, go. Jack, should be straight up.
Man, a quarter of our students are at a quarter were late today.
Oh my god.
Yeah, God, y'all killing me.
Come on, guys.
Can you get the, can you try the thing?
No, just erase the, use the car wash fund to erase the. Well, I know, it's not easy, but just put a little bit of it.
There is no spray, by the way. What is the thing? Can we be a little more specific? Use some math words. Okay, it's in our equation.
H and X.
It H and X. It's H and K, right? We all did well on our y-intercept, solving for what value is 0 for y-intercept? X. So we just plug in 0 for x. X-intercept is what trips us up, and that's okay. That's the point of this. So to find an x-intercept, what's always true? Y is 0. So my function is y equals x plus 5 squared minus 4, and I want y to equal 0. I can set these two equations equal to each other. So now I have x plus 5 squared minus 4 equals 0. I need us all to pay attention right now. Mason, this is where it gets dicey. So I need you up and over here. I need us focused. I don't want anybody to mess up on this. Let's get this done, okay? This is a multi-step equation. What is the first step in solving it? Gotta get rid of that negative 4. What's the inverse of minus 4? Plus 4. So I'm going to add 4 to both sides. So now I have x plus 5 squared equals 4. Now, my x plus 5, I want x all alone. But that x and that 5 are trapped by the squared. How do I get rid of a squared? Square root, okay? I just want to see because 2 squared equals 4. Square root of 4 equals 2. So I started with 2 and I ended with 2. Those are inverses, okay? So I'm going to take the square root of both sides. Everybody pay attention. When I take the square root of a number, it is not just the positive of that number. It's plus or minus that number. And here's why. What is negative 2 squared? Positive 4. And what is positive 2 squared? Positive 4. I got the same number when I use negative 2 and a positive 2. So when I take the square root of 4, my answer can either be a positive 2 or a negative 2. So now I have x plus 5 equals plus or minus 2. What I would do is split this up into two separate equations. I'm going to have x plus 5 equals positive 2, and then x plus 5 equals what? Negative 2. Now I solve each of these like a normal equation. How do I get rid of this plus 5? Subtract 5, which gives me x equals negative 3. And how, again, same thing. X equals negative 7. So my x-intercepts are what?
-3, -7. Oh, 0. And then -7, 0.
We all should have Fourier models that talk about vertex forms. I would write this down. I want us to be so proficient in this. I know it seems tricky at first. Now I have to remember to do two different things. But if you just remember it's plus or minus, when you take the square root, you're good to go. So I'd make a note of that somewhere that you can look back at. Okay?
That's cool. I get it.
You get it?
Yeah.
You don't have to write it down?
You get the number
Yeah, but sometimes it's going to be a lot more complicated. It's just solving a normal equation. But yeah, so you want this by itself. So you add 4 to both sides. You're just trying to get x one. Okay. Does anybody have any questions about this? Because I still need to solve for x, right? But since this is plus or minus 2, as to not mess me up when I do my math, I'm gonna put that in 2 separate equations. X equals 5 equals positive 2, and x equals 5 equals negative 2. So that way, I can see clearly what my 2 roots are.
She was saying that
Honey, did you print those things?
Yeah, it should be on the printer. Sorry, I was trying to get you guys. One thing I've noticed are when you do this, that they forget with that plus or minus, that they have to have two root questions. Two x intercept, well, I have to put two roots. But you have to have that detail, that's like a helpful reminder.
Like,
With a quadratic, there needs, it doesn't have to be two different roots, but it needs two different roots, which is why it's a plus or minus. I just noticed that helps.
I just talked about the root ones and they.
Yeah, and 100%, and I thought about that too, it's just that everything, when we inevitably just do one, it's like, well, how many roots are you supposed to have?
Yeah.
Doesn't that make sense? Just
Yeah.
add the detail.
Alright, so I just passed out, what we are doing next. Me and Mr. Kitty just talked about it, some of you might have heard that conversation. How many roots do you need to have in solving for quadratic? You need 2. That's another reason we have to have that plus or minus, right? If it's just a positive 2, how many roots are we gonna get? 1. That's not right. Then you have plus or minus. Make sense? Beautiful. Alright, so.
What?
I need Adriana for my math review.
Didn't you do, someone do that yesterday?
I didn't call him yesterday.
Who talked to you yesterday? I mean, I guess it's fine, we just need to be quick, because we got learning to do.
I'll give you all a second, just to write this stuff down. Once you guys have it written down, you guys are going to go ahead and do A, B, and C. Don't do D. Throw that out the window. I mean, if your group gets done with A, B, and C and you want to try it, you should. But just focus on A, B, and C with your group, getting those 3 done. That is a fraction. Oh, you can do a fraction.
Not there. No.
No, I know.
You got it. We should do it. I don't know. You got it.
I'll be good there.
Are you moving?
Fall over.
Oh. I don't think that wall is magnetic.
Oh, you won't. You drop me.
Oh. No.
It's
No.
not gonna work.
Sorry.
Oh, what I did, Tyler, the other day, is I grabbed one of those, here, come back over here.
Put it on the window seat.
No. Magnetic?
Oh, yeah.
Okay, well, I thought you were just turning around.
In front of this action. All right. I just want to point this is, I want y'all to read this equation with me, okay? Hey Jordan, can you take care of the dog, please? Thanks, sir. I want y'all to read this equation with me, okay? Now, first off, I want to remind you, what is the order of operations to simplify an expression? Okay, what does that mean though? That's an acronym, those are letters. What do you mean by PEMDAS? Okay, so let me write this out really quickly. Order of operations to simplify. So, parentheses, exponents, or, okay, so multiplication. I know, by the way, a lot of us may think it's multiplication then division. Not necessarily. It depends on which one comes first. And then addition / subtraction. Okay, so I'm going to do a quick run through that I used to do when I taught Algebra 1 and sometimes with geometry, because I want y'all to understand this. What is the most basic mathematical operation you ever learned? Adding and subtracting, right? And so, notice that's at the bottom. That's the last thing we do. But what do I get if I repeatedly add? I get repeated addition is multiplication, right? Okay, okay. Do you know what I get if I repeatedly subtract? Division. Like, repeated subtraction is division. For instance, okay, let's establish this. What is 8 divided by 2? 4. Woo-hoo-hoo-hoo. That was tough, I know. But watch this. 8 minus 2. What's 8 minus 2? 6. Minus 2 again. 4. Minus 2 again. Minus 2 again. How many times did I have to take 2 out? 4 times, right? Like repeated subtraction is division, okay? Then, you know what I get when I repeatedly multiply? An exponent. You know what I get when I repeatedly divide? I also get an exponent. How can I rewrite 3 times 3 times 3 times 3? 3 to the 4th, okay? You know what 3 to the negative 4 is? Well, 1 divided by 3, 4 times, okay? So, I need us to recognize these things. It's going to help in a second, okay? Now, all that to say, and so I will point this out, positive exponents, negative exponents, right? Repeated multiplication is a positive exponent, repeated division is a negative exponent, and so that's the order of operations to simplify. Well, I want to solve for this x. So what's the very first thing happening to x? Well, it's being grouped, and before the square even, I do have parentheses, right? Because here's the thing, what should happen before I subtract if I take out parentheses, what would happen first? An exponent, right? But I want to do the subtraction first. So grouping helps me know, hey, do that weaker operation first, okay? So read from x, what's happening to x? It's being subtracted by 1, okay? What's happening to x minus 1 by this order of operations? It's being squared, okay? What's happening to x minus 1 squared? It's being multiplied by 3, okay? Now, I want you to think about that x like the inside of an onion. Can you get to the inside of an onion right away? No, what do you have to do? Peel it, right? You start on the outer layer and you peel away the outer layer to get onto the inside, right? What was the outermost layer we just talked about? Multiplication at times 3. So what's the first thing I need to peel away? Well, I need to peel away the multiplication by 3 by dividing by 3, okay? I'm peeling away the layers of this onion. What's a third of 48 or 48 divided by 3? Anybody know? 16, yeah. Now x minus 1 squared. And then start over again. What am I solving for, Marcus? Thanks. I'm solving for x, right? So what's happening to x first, Caleb? It's being subtracted by 1, right? Taj, what's happening to x minus 1? No, what's happening to the x minus 1? It's being squared. Yeah, there you go. X minus 1 squared, right? Is there anything after that square, or is that my outermost layer of the onion now? That's the outermost layer of that onion. So Bree, what do I need to do to peel away that outermost layer of the onion? So, well, not just, and so I want to caution y'all. I need y'all to hear me on this. This is a result. What I need to do is I need to take the square root here. I'm trying to peel away the layer of this onion. So I'm getting to this x. That's the first thing I do. Now, because I did this on the right-hand side, what do I now need to do? I need to do it on the left-hand side. What's that called? We've talked about this. It's a type of property. property of
Elimination.
no,
Equality.
equality.
That's close.
Yeah. What you do to one side of the equation, you have to do to the other side. If you don't do it to the other side, you're changing the equation. We don't want to change the equation. We just want to look at it in a different form. You with me, Jacayla? Good talk. All right, what do I get now as a result of the square root of that 16 on the left-hand side?
4.
You sure about that?
Guys. When you take a square root of a number,
Okay, we need a positive and a negative 4. Guys, I need y'all to remember this. Because the idea is what we're asking, when we take the square root, what we're really asking is what was squared to get 16? What could I square to get 16? 4. Is there anything else? Negative 4. Right. Positive 4 squared and negative 4 squared are equal to 16. So I need a positive and a negative. Now I know Ms. Kowalski said she wants y'all to split the equation up. So x minus 1 equals 4 and x minus 1 equals negative 4. I'm not that picky. You pick what's best for you. I like to be simple. I like to just add 1 to both sides. And then I think through it. Hey, what's 1 plus 4 or a positive 4 plus 1? 5. What is negative 4 plus 1? Negative 3. Now what should you do at the end of all this to check and make sure you did this correctly? We'll substitute it back in, right? Because what should these values do to that equation? Make the equation true. It'll equal 48, making the equation true, right? Notice what's 5 minus 1? Oh, you remember that 4 we got earlier? What's 4 squared? 6. Oh, that's 16 we got right there? And what's 16 times 3? The 48 we started with. Notice it is undoing those operations. And we can substitute it back in and get back to where we started. Okay? So, peel away the outermost layer of that onion. Start with your variable. Read that expression until you get to the last operation. And the last operation is what you want to undo. Use an inverse. Undo that thing. Peel away that layer of that onion. We go with that? Questions? Comments? Concerns? Y'all ready for D? I feel like we're ready for D. Oh, yes!
oh, y'all can do D now. Now that we went through all of that, y'all can do that.
Read let's just read it together. Mason, what's happening to X first? I know your name's not Mason, but Mason's not paying attention. Mason, what's happening to X first? You're hurting me.
You do know. Read it.
Look at that X. Yes, dude, it literally has inside of parentheses X plus 5, right? Marcus, what's happening to X plus 5? Multiplied? Okay, everyone go with being multiplied? Wait, why squared? Okay, but how do you know squares next? Remember, parentheses, then exponent. So Marcus, remember, it's an exponent before multiplication. So I know that's out front, but we've got to follow the order of operations. It's x plus 5. What's happening to x plus 5, Marcus? We just said it, dog. It starts with an S, it's being squared. There we go, right? Exponent. Okay? Tyler, what's happening to x plus 5 squared?
Multiplied by 1/2.
Multiplied by 1/2. What's happening to the 1/2 times x plus 5 squared? Being subtracted by 18. Peel away the outermost layer. Let's go.